Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of first secondary, we are going to illustrate points of Unit 2 quantitative chemistry. We are going to discuss some points of our unit today. Okay, our objectives illustrate or identify the meaning of stereochemistry. Second one, identify the meaning of mole. Identify molar mass, molecular mass, and formula mass. Okay, let's start. What do we mean by the word stereochemistry of chemical reactions? Okay, if we have any kind of reactions that happen between kind of compounds or elements called reactant, and they give as at the end of reaction they give product. So here we have the product here that we study the amount of or the aspects of chemical reaction. So if we going to illustrate the meaning of stereochemistry, it is the study of the quantitative aspects of chemical reactions, how this reaction happen, or what we are taking from it quantity as a reactant to give a product as the quantitative chemistry, or our title as whole of the unit. Okay, let's go. What is the meaning? Also, we have here the study of quantitative relationship between reactant and products in a reaction. Okay, this is the meaning, or identify. If we want to identify the word stereochemistry, it is the study of quantitative relationship between the reactant and the product inside the reaction. We have steps here. Okay, what happened inside the quantitative relationship? Here we want to know what happened inside it. Okay, at the first we will use to answer questions about what? About how much amount of reactant I will use. Okay, it is the first one. And what is the product will be formed. This is the other point. Second one, if I want this much product, how I take reactant to give this amount of product. Okay, this is the other point. Another point, questions how real life applications practically in manufacturing different products or different elements around us or compounds around us. If we have to know, it allows us to convert the mass of substance to number of particles. If we make a decomposition like atoms or ions or molecules, how much it contain. Okay, another one, these numbers can be really large, so they are counted in groups. If we can collect them, we can make polymer or huge substance or giant substance. The last point that stereochemistry give us, much like when we count a lot of pens, we stack them in tens and count by tens. Okay, we said we have group of tens or group of 12s. Okay, we can collect them in what? In, we said pens. Okay, then we start to get from it, or if we can collect some amount of material together, we have the word mole. What is the meaning of mole? Mole, it's a measuring unit or unit of measuring what? Here we have, when we start chemistry, we have atoms, molecules, ions, or compounds like ionic or covalent. Each one I want to measure them. Okay, I collect them, or one of the scientists collects them in a group and take a unit for measuring it. We called it mole. So the group or unit of measure used to count atoms, molecules, formula units, or ions of a substance. This is the meaning of the word mole. Okay, if we guess what we are talking about, one mole of substance has a particular number of particles in it. Okay, so we have particles inside one particle. Okay, this means that we can divide it into small in amount. Also, much like one doesn't always mean one doesn't, it means it anything that contain 12, anything like a cup of tea contain 12 buckets. So here we have 12 eggs in the picture, 12 oranges, 12 gold bars. So it means that dozen here, one dozen contains 12 from anything. Okay, so I wanted to measure the atoms. Atoms are very tiny, as so small as I can't make it or take it as a one atom to measure or to count it. So we have grouping. We use it to count them must be very large as we take it. So we can collect some atoms together and measure it, or at the end we can call them one mole. Okay, how many particles are there in one mole? We wanted to know how many particles are in a mole. Suggests that if we have a number of particles in a mole equal this whole number, it's a very big number. You think it's very small or big? It's very big. If we collect these zeros, a lot of numbers or a lot of zeros here, they will give 23 zeros or 23 tens. So the number of particles in a mole, we can collect them in a whole number equal 6.02 times 10 power 23, or this zeros also give the numbers here, or what we called what mole. Okay, the scientists that collect this or measure this amount take the name of it, and we called it what? Avogadro's number. We can collect the number of particles in a mole in a word, what? Avogadro's number. So Avogadro's number, it is a number indicate the number of particles or any ions or any atoms inside a one mole. One mole equal what? Equal 6.02 times 10 power 23. So using this amount or this number, we can easily count the number of particles in all kinds of things around us. We can measure it easily by this unit, or we called it what? Mole or Avogadro's number. If we wanted to counting particles in a mole, okay, we have, suppose we have carbon atoms, one carbon atom. Okay, we have here, there are 6.02 times 10 power 23 carbon atoms in a mole of carbon. So if we have amount of carbon here, or 1 mole of carbon contain what? Contain the amount that equal Avogadro's number time carbon atoms. Okay, another one. If we want to get the number of moles or 1 mole of carbon dioxide, it means that we have Avogadro's number time carbon dioxide molecules. So 1 mole equal any Avogadro number time any amount or any kind of substance that we have taken. Okay, so a mole of carbon means here we have what? We have 6.02 times 10 power 23 carbon atoms. And also 1 mole of carbon dioxide contains or equal what? Equal 6.02 times 10 power 23 carbon dioxide molecules. Also 1 mole of sodium here. It is a metallic element. Here we have equal what? Equal 6.02 times 10 power 23 sodium what? Sodium atoms. So here we have also a mole of marbles. We have marbles here in the picture. Equal what? Equal 6.02 times 10 power 23 marbles. So we have number of anything that we can convert it into amount or a mole inside or regarding to Avogadro number time the amount of substance that we have. Okay, that's a lot of marbles here. We have the size of a 1 mole or a mole of a substance changes according to the substance. The bigger the substance, the more space of a mole of the substance takes up. If we have a big size mole or big size substance that have a large or there is big amount of substance or particles from this substance. Okay, but the number of particles in a mole is always the same. Okay, if we have any mole of substance and mole of the same substance, the amount of particles or the number of particles in a mole is always fixed or always the same, that giving Avogadro's number inside the mole time the kind of substance that we have taken. If we have a mole of water contains what? Okay, mole of water contains of 2 atoms of hydrogen and 1 atom of oxygen. So 1 mole or 1 molecule of water, it means that it contains kind of atoms. What is the amount that we can measure? Okay, if we measure that, or suppose that we have Avogadro's number here time the molecules of water. Here we have how much of molecules of water? We have 1 molecule of water here. So if we want to get a mole of water, it means that it have or it consists of what? Avogadro's number 6.02 times 10 power 23 times 1 molecule of water. Another point, if we have this molecule dissolved in a substance, we have here 1 mole of water also. So we have here 1 mole after dissolving or after taking the amount of Avogadro. We take the molecule time Avogadro number, that give at the end what? 1 mole of water here inside the beaker. So we can measure it as well.